Another form of denormalization is called partitioning. There are two types of partitioning. One is called horizontal partitioning, and the other is called vertical partitioning. Horizontal partitioning means dividing a table horizontally. So you have multiple partitions of the table here. And each partition has a set of records. And the vertical partitioning means you're dividing the table vertically, right? So each partition has some fields. So that's the differences between these two types of partitioning. And horizontal partitioning is useful for situations where different users need access to different roles. Like for example, if you have people who only need to access customer information of customers from Omaha, or customers from Chicago, or customers from Los Angeles, then you can horizontally partition the tables, and they only need to access the data they need to access, right? And also for security reason, that's a good thing to do, right? So that people can not see the data they are not supposed to see. For vertical partitioning, it's useful for situations where different users need to access different columns. Like for example, your human resource manager may need to see certain fields, and your business manager may need to see certain fields. When you do vertical partitioning, you need to duplicate the primary key in both partitions, because when you break the table into two vertically, the primary key is only in one of the partitions, right? So what you need to do is you need to duplicate the primary key in the other partition as well. There are a number of advantages for partitioning. Well, the first advantage is for efficiency. The records used together are grouped together, and also because you are handling a smaller volume of data, then the processing can be more efficient. The other advantage is local optimization. Each partition can be optimized for performance. For each partition, you can set a different index. For each partition, you can use a different file organization in order to improve the performance. Also for security and recoverability, right, because users are only seeing the data they are supposed to see. And also for recoverability, it's easier to recover part of the table than recovering the whole table. Another advantage is for load balancing. When you use partitioning, you can use multiple processors to process the data. Right? So you can actually do parallel processing instead of depending on just one processor to process the data. But there are also some disadvantages of partitioning. One is inconsistent access speed between the partitions. Like one partition is much bigger than the other partition, so obviously the performance is going to be different for different partitions. It adds an extra level of complexity and also requires extra space for update time. Every time you update the database, it will need to update the partitions also. There are a number of partitioning methods you can use to partition the tables. One partitioning method is called key range partitioning, and that means you're partitioning the table based on the value of one field. For example, we can partition the table, the customer table, based on the value of the city field. So every city has its own partition. The other partitioning method is called hash partitioning, and that's using the hash algorithm. For example, if you have 1,000 records, you're going to find the prime number that's closest to 1,000 and less than 1,000, which is 997, right? So then you're going to use the primary key of the table and divide it by 997, and you get a number plus a remainder. The remainder can be 1, can be 5, can be whatever. Okay, so using this remainder, you can partition this into different partitions. For example, if the remainder is an even number, you're going to put it into one partition. If the remainder is an odd number, you put it in another partition. The advantage of hash partitioning is that it's random partitioning, and also the partitions it creates are usually pretty even. The size is pretty even. If you use the key range partitioning, sometimes you may have one partition that's huge and then another partition is really small. So that's the advantage of the hash partitioning over key range partitioning. And of course, you can also do a combination of the key range and hash partitioning, which is called composite partitioning. You can do a key range partitioning first, and then you can do a hash partitioning within the partition. Another form of denormalization is called data replication. The reason for data replication, one is for performance, the other is for security. It's easy to understand why you want to replicate the data for security reason. You want to keep multiple copies of the data, right, in case one copy is corrupted. For performance reason, you may want to keep data in multiple places so that they can be processed simultaneously, and also they can be processed closer to the user. For example, if your company has locations in multiple parts in the US, and you keep a copy of the data at every location, then you don't have to remotely access the database in another location. Partitioning or data replication is always best for data that is not updated frequently. If you have to update the data frequently, then if you have multiple copies of the data, then it becomes a hassle to update multiple copies. And also that if you forget to update it, then there will be inconsistency in the data. Physical files is a named portion of secondary memory allocated for the purpose of storing physical records. A number of concepts here. Table space, that's a set of disk storage elements used for storing tables. And extent, contingent sections of disk space. So within a table space, you have many extents. When you run out of space in the table space for storing data, you just assign more extents to this table space. So these are the terms used for physical files. There are a number of different ways to link two pieces of data or two records in a database. You can do sequential storage, which means you go from the first record to the next record and so on, just like a tape, cassette tape, right? Or you can use pointers to link one record to the next record. And a pointer is usually more efficient. It's faster for searching for a record than the sequential storage. The factors that you need to take into account for selecting file organizations are faster data retrieval, efficient storage, accommodating growth and security, and so on. And there are three types of file organizations: sequential, indexed, and hashed. This is an example of the sequential file organization. As you can see, everything is listed in alphabetic order. If you're looking for a certain record, what you do is you go from the first record and then continue on until you find the record you are looking for. Just like cassette tape, right? You have to forward or rewind until you find the record you are looking for. So sequential files are usually good for small tables, because if you have a really large table, sequentially going through every record to locate the record you are looking for is not very efficient. And then index the file organization. What it does is it will index your records. It's kind of like the index at the end of the book. By searching the index, you can find the page number where you can find the word you are looking for, right? So you can go directly to that page and find the information about this topic. That's what index is. So it will allow you to quickly go to the location of that record. For large files, index the file organization is usually a lot more efficient than the sequential file organization. There are a number of different types of index you can use. For example, this is called a B-tree index, and that stands for binary tree index. As you can see, if you're looking for example, pencils, well, you go to the first level of B-tree index, and then you say, okay, I'm looking for something that starts with P. So it has to be between P and Z, right? So I go to this subset, right? And then you go to the second level index here and say, okay, it should be in this set. And then you go to here, and then you sequentially go through the set here and find pencil. So it's a lot more efficient than going through the whole file sequentially. You also have hash the file. Hash the file again uses the hash algorithm, like what I just described. You create an index for each record, and you sort the record using that index. And you can also use something called a bitmap index. Bitmap index is kind of interesting. You can use this when you only have a few values for the field. So for example, in this case, you have 10 different products. However, you only have 4 different prices for the products, either 100 or 200 or 300 or 400. What you can do is you can create a bitmap index. For example, for product 1, the price is 100, so you put 1 bit here. For product 2, the price is 300, so you put a 1 here. For product 3, it's 100. So you put a 1 here, right? For product number 7, 1 is in the row of 300. That means the price is 300. The bitmap index is very efficient because you're only processing 1 bit of information. And also you have something called join index. Join index is only used in data warehouses because in data warehouse you need to access a lot of data. So you want to ensure that the join operation can be performed efficiently. So what you do is, let's say for example, you have a number of tables here. You have the order table and the customer table. And these two tables need to join frequently. Maybe one question that the user will often ask is, which customer placed which order? You can create a join index that gives you the row number of the customer ID that matches the order ID. So this way you can just go to the join index and quickly locate the matching fields. Most of the time it's only used for data warehouses for performance reasons. Clustering files, another technique you can use to improve the performance of your database. For example, if 2 files or 2 tables are often processed together, then it makes sense to put them next to each other on the hard drive, because this way they can be processed together more efficiently. So that's called the clustering files. It's very useful for improving performance of the joining operations. And in Oracle, there is a command called create cluster, and you can use this command to create a cluster of files so that they will be stored next to each other on the hard drive. When do you want to use index? Well, there are a number of rules you can follow for using index. The first rule is only use index for large tables. If you only have a small table, let's say 10 records, then you can just sequentially go through the table to find the record you are looking for. There is really no need for creating any index if it's a small table. The second rule is index the primary key of each table. Well, the reason is because the primary key is always unique for every record. It makes sense to index the primary key. And then the third rule is index the search field. If you're using a field to search for records frequently, then it makes sense to index it, right? Because this way you can quickly find the record. And the fourth rule is fields in SQL order by and the group by commands, because you're going to be sorting the results using the order by field, and also you're going to be grouping records using the group by field. So you probably want to index these two fields. And also when there are more than 100 values but not less than 30 values. Why is that? Well, let's say if you have 1,000 records, okay, and the field you are going to index has 100 values, 100 different values. So what it means is, on average, there will be 10 records for each value. So how index works is, well, it will create a table with 2 fields. One is the value of the index, the other is the location of the record. In this case, if you have 1,000 records and 100 different values, so on average, you have 10 records for each value. All these 10 records, let's say value 1, okay, location is XYZ. And then you go to the location XYZ on the hard drive, and you will find that there are 10 records because all of them have the same value. What you do is you go sequentially through these 10 records and find the record you are looking for. But what if you have only 30 values? Then 1,000 records, that means on average you have about 33 records for each value. So that means you go to location XYZ and you will see 33 records, and you have to sequentially go through 33 records, right? So sequentially going through 33 records, it obviously takes more time than sequentially going through 10 records. So that's why if there are very few values, different values, then it doesn't make sense to index it, because you have to sequentially go through them anyways. You want to avoid using indexes for fields with long values, because when you create index, you're creating a 2-field table. And if you need to store these long values, it's going to create a large table. Description field is probably not a good field to index. The DBMS may have limit on the number of indexes per table and number of bytes per index. For example, some DBMS will say you can only have 16 index for each table. But I guess in most cases you don't want to have 16 index for a table. Null values will not be referenced from an index. So it's very important that you only index the field that does not have null value, because the null value is not going to appear on the index. If you go to the index of book, there is not an index item for space, right? The last rule here is use index heavily for non-volatile databases and limit the use of index for volatile databases. Why is that? Well, because when you create an index, if you update the database, let's say you insert a new record, what's going to happen is it also needs to update the index. If you change the value of the record, it also needs to update the index. If the table is very volatile, then the index also needs to be updated very frequently. So that's why you don't want to use index on these volatile tables. You will only want to use them for non-volatile databases. There are some hardware solutions to improve your performance in database. The RAID technology, which stands for Random Array of Inexpensive Disks, that's often used for parallel processing. Instead of using just one disk, now we are using multiple small disks. There is a technique called striping we use on these RAID disks. So you put a record 1 on disk 1, record 2 on disk 2, 3 on disk 3, 4 on disk 4. So when you process this database table, you can process all 4 disks simultaneously. Read them as one logical disk. So this is going to improve the speed fourfold because you are reading 4 records at a time. However, the problem with the RAID technology is that the reliability is not there. Think about this. If the reliability of the disk is 98%, and that means, 2% of the time the disk is not going to be working, right? Well, with one disk, the reliability is 98%. If you have 4 disks in the RAID setup, what's the reliability of these 4 disks? Well, it's 98 times 98% times 98% times 98%. So it becomes like 90%. So in order to resolve this problem, what you can do is you can create what's called a RAID 1 setup, which is a redundant setup. You have 4 disks, and then you have 4 redundant disks. So in case one crashes, another one will kick in. So this way, it improves the reliability. But obviously, the problem is it's very expensive. Now you have 8 disks. There are even more expensive solutions like RAID 2, RAID 3. You can choose the data architecture that's going to give you better performance. For example, the legacy data architecture, the hierarchical database, and the network database models, obviously they give you better performance. But today, the hardware is so powerful, the performance difference between the relational database and these legacy database models is probably negligible. When it comes to data warehouse, you may want to use multidimensional data model or star schema that will allow you to quickly locate the record. We'll talk more about the star schema when we get to the data warehouse chapter. There are some query optimization techniques that you can use in order to improve performance. For each database management system, there is something called a query optimizer. And that's an engine in the DBMS that's going to analyze your query and figure out the best way to process your query. And how does it decide the best way to process your query? Well, it's really an artificial intelligence system. It will look at the stats of all the previous processing. For example, how much time it takes to process table X and how much time it takes to join table X and Y, and then try to find out, the best way to process your query. So it's an automatic tool that's going to find the best way to process your query. Sometimes database administrator may know the table, know the situation much better, and you can actually override this automatic query optimization and create your own query execution plan. We'll talk more about this when we get to SQL Server. There is a way to create your own query processing plan to optimize the speed of queries.